Students of the Homework Up video, page 843. Let's go ahead and get started with the homework for today. Numbers 5 and let's see, numbers 5 and 13 through 19 odd are all going to be solved by substitution, which is what the directions say to do. So here we go. Let's solve number 5 using substitution. Let's take our top equation here. X minus y equals 0. It would be easier to get x by itself, so I will bring y over here, make it a positive y. So x equals y. I will come down here to my other equation, and where x is, I will substitute y. Okay, so 5y minus 3y equals 10. 5y minus 3y is 2y equals 10. Divide both sides by 2. Y equals 5. Now students, if you look right here, x equals y. So if y is 5, then x also has to be 5. Okay, so there we go. 5, comma, 5 for number 5. Alright, moving on to number 13. Number 13. Okay, we're going to use substitution. Now students, listen. Normally when you have a fraction like this, you would want to multiply this entire equation by 6, the denominator here, to get rid of your fraction. But since we're using substitution, I'm going to get x by itself anyways here. So here's what I'm going to do. I'm going to bring the negative, here's my equal sign. I'm going to bring my negative x over here so that it becomes a positive x. I'm going to bring my negative 7 over here so that it becomes a positive 7. So positive 7 minus 5/6 y. There we go. That's what x equals. So if this is what x equals right here, I'm going to take my other equation, and where the x is, I'm going to substitute this right here in for x. Okay? So here we go. We'll do it right over here. 6, and then parentheses. And instead of putting an x, I'm going to put 7 minus 5/6x. And then plus 5y equals negative 3. Okay, let's go ahead and simplify this left side over here. And actually, this should be 5/6 y. 5/6 y right here. There we go. Now take your 6 and multiply it through. 6 times 7 is 42. And 6 times 5 over 6 would be negative 5y. Then bring down your positive 5y. Okay, we're going to go ahead and simplify. Our y's cancel out completely, and you're left with this. 42 equals negative 3. Well, students, that's no solution. Okay, now, please listen to me carefully. Students, if everything had canceled out on both sides, and you were left with 0 equals 0, that's when your answer is infinite solutions. Okay? But in this case here, everything did not cancel out on both sides. Just your y's canceled out. So the answer to this would be no solution. In other words, these two lines here, if you were to graph the graphs of these two equations, they would not intersect anywhere. Okay? Alright, number 15. Number 15. Okay, here we go. Now, taking a look at number 15 here. I want to get one variable by itself. It looks like it'd be easier to get this y by itself. So I'm going to take this bottom equation here, and I'm going to write y equals, I pick up your negative or 2x, bring it to the other side and make it a negative 2x. Y equals negative 2x, okay? So if y equals negative 2x, go into your other equation up here, and where the y is right here, you're going to put negative 2x. Okay, so here we go. X squared minus, and then y, I'm going to put negative 2x equals 0. So now I have, students, x squared minus a negative is plus 2x equals 0. Okay, and now look what I have, students. I have a quadratic equation set equal to 0. I can factor this, pull out an x, and I'm left with x plus 2. Now take each group and set each group equal to 0. X equals 0. Now take this group here, set it equal to 0. X equals negative 2. So I have two x values, okay? 0, comma, question mark, and negative 2, comma, question mark. So now what I have to do, students, is I have to take these two values and put them in for x, okay? So I'm going to put a 0 in for x right here. 2 times 0 is 0. So one answer here would be 0. Now put negative 2 in for x. And y would equal positive 4. So that means if you were to graph these two equations here, they would intersect in how many places? They would intersect in two different places. Okay? Alright, moving on to number 17. Okay, once again we're looking at substitution. It would be easier to get this x here all by itself. So x minus y equals 0. Bring the y over and make it positive. X equals y. Okay? So where the x is up here, let's see. No, I don't want to put a y. Yeah, I can put a y. That'd be fine. So where the x is here, I'm going to put a y. So I have x cubed. So put a y for x. Y cubed minus y equals 0. Okay? Now here we go. Y to the third power is y cubed. Factor out a y. And you're left with y squared minus 1. Now look, I know the square root of this term, and I know the square root of this term. The first term is positive, and the second term is negative. We learned this during the way back in the first week of school. We can factor that. It's a perfect square. So the square root of y squared is y and y. The square root of 1 is 1 and 1. Make one positive, make one negative, and we are moving along, okay? So take this group here, set it equal to 0. Y equals 0. Take this group here, set it equal to 0. Y plus 1 equals 0. So y equals negative 1. Take this group here, set it equal to 0. Y equals 1. So we have, students, 3 y values, okay? Now, however, look guys, look right here. X equals y, do you see that? X equals y. So this will be easy. This will be very simple. When y is 0, x is 0. When y is negative 1, x is negative 1. When y is 1, x is 1, because x equals y. So, are you telling me, Mr. Earhart, if I were to graph these two equations, they would intersect in 3 places? That is correct, yes. If you were to graph these two equations, they would intersect in 3 different places, okay? Alright, moving on to number 19. Number 19. Okay, we'll slide this up here. And now students, look at number 19. We're using the substitution method. And look, there's no letter to get. You don't have to get any letters by themselves. It's already done. Look right here, guys. Look, y equals x squared minus 1. So I'm going to pick this up and put in for y right here. So I have x squared minus 1 equals x cubed minus 2x plus 1. Now students, we should know what to do here. This is a third degree polynomial function, so you want to get one side equal to 0. So bring the negative 1 over, make it a positive 1. Bring the x squared over and make it a negative x squared. So I would have 0 equals, your x cubed comes first, then your x squared would come second, then your x would come next, and then your constant term, 2. Okay? Now I can solve this. This isn't difficult at all, guys. This is pretty simple. I'm just going to factor this, and we know how to factor a 4-term expression. 0 equals, pull out what's common in the first 2. And then here, whenever this is negative, pull out a negative, and pull out what's common in these two. It'd be a 2. and you're left with x minus 1. Because negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Notice your parentheses match, and they should match. So here's your matching parentheses. Write them once. And then your other parentheses, x squared minus 2. Okay? Now take each parentheses, set it equal to 0 and solve. Okay? So here we go. Take this and set it equal to 0 and solve. X would equal 1. Now take this group, set it equal to 0 and solve. Okay? Bring the 2 over and make it a positive 2. Take the square root of both sides. Plus, minus, square root of 2. So we have 3 x values. One x value is 1. Another x value is square root of 2. And another x value is negative square root of 2. So now all that we have to do is find the corresponding y values. And that's pretty simple, guys. Look. You are more than welcome to use this equation here. That's totally fine, but it's a lot more work. I'm going to use this one here. Y equals x squared minus 1. So where the x squared is, I'm going to put a 1 in for x. Well, 1 squared is 1. 1 minus 1 is 0. Okay, so we'll put a 0 right here. So there's one ordered pair. Okay, now let's put in square root of 2. So y equals, and then for x I'll put square root of 2 squared minus 1. Well, whenever you square a square root, you get what's on the inside, so 2 minus 1. 2 minus 1 is 1. Now I'm going to put in negative square root of 2, and you're going to see, students, that you will get out the exact same answer, which is 1. And I'll show you that real quick. Y equals parentheses negative square root of 2 quantity squared minus 1. Now, when you square a negative, it's positive. When you square a square root of 2, you get 2 minus 1. So y equals 1. So there we go. If you were to graph these two equations, they would intersect in 3 different places. Okay? Alright, let's go ahead and continue on. Okay, starting with number 31, students, we're now going to use linear combination. Okay, linear combination. So here we go, number 31. Well, look, guys, your y's are all ready to cancel. So let's just go ahead and add the two equations together. X plus x is 2x. 2y negative 2y cancels out. 4 plus 1 is 5. Divide both sides by 2. X equals 5 over 2. Alright, now it doesn't matter which equation you use next. I'm going to use this one here, just because I feel like it. So for my x right here, I'm going to put 5 over 2 minus 2y equals 1. Now I'm going to multiply everything by 2 to get rid of this fraction. So I'm going to multiply the entire equation by 2. 2 over 1 times 5 over 2 is 5. 2 times negative 2 is negative 4. And 2 times 1 is 2. So I got rid of my fractions. Now bring your 5 over and make it a negative 5. Negative 4y equals negative 3. Now divide both sides by 4. And a negative divided by a negative is positive. 3 divided by 4 is 3/4. So your answer would be 5/2, comma 3/4. Okay, let me check that real quick. That is correct. And let's move on. Number 39. Students, let me help you here, please, and give you some advice. Whenever you have an equation with decimals like this, move the decimal the same amount of places in each term so that you have no decimals left, okay? I'm going to move the decimal one place, but I got to move this one place too, and this one place too. It's the same thing as multiplying this whole equation by 10, okay? Same thing. So here we go. I now have 18x plus 12y equals 40, okay? All over 9x plus 6y equals 3. Now, students, please listen to me. Let me teach you a shortcut here. Look, whenever you can reduce an equation, reduce it. For example, this bottom equation here, 3 goes into everything, so divide everything by 3. Why would you do that, Mr. Earhart? So you have smaller numbers to work with, okay? Alright, now, let's see, what goes into all these numbers? 2 does, 9, 6, and 20. I think that would be it, so I'm going to reduce this equation here by 2. So 9 plus 6y equals 20. There we go. Now, let's go ahead and use these two equations here. Alright. Let's eliminate our x's. So I'm going to multiply this bottom equation here by a negative 3. A negative 3. So we're left with negative 9x, negative 6y, negative 3. Okay, I'm going to cross all this off. Let's add these two equations together. Hey, look what happens. Your x's cancel, your y's cancel. You're left with 0 equals 17. Now remember, students, if you would have been left with 0 equals 0, then the answer is infinite solutions, okay? But in this case, we're left with 0 equals 17, so the answer is simply no solution. If you were to graph these two equations, they would not intersect anywhere, okay? Alright, moving on to number 43. Number 43. Now, like I taught you before, let's get rid of our decimals, okay? So here we go. I'm going to move this decimal one place, one place, one place. So 25x minus 30y equals 15. Now, same thing down here in the bottom equation. Move all of your decimals one place. So 20x minus 24y equals 12. Now, like I taught you in the last problem, let's go ahead and reduce these equations, okay? Let's reduce them. So the top equation here, 5 goes into all of these. So 5x minus 6y equals 3, okay? Now here, 4 goes into all of these. So 5x minus 6y equals 3. Look at that. When you reduce the fractions, they end up being the same. So now, I'm going to go through and we're going to use elimination, okay? Like we're supposed to. But really, if you can see right away, we have two identical equations, then we know they're going to fall right on top of each other. We know our answer is infinite solutions. But I will still show you how to do that, okay? So I'm going to go through and multiply the bottom equation by a negative 1, okay? And when I do that, this will become negative, this will become positive, this will become negative. Add them together, everything cancels out. You're left with 0 equals 0. Now, students, here's what I need you to do. Please listen. In pre-cal, it is not good enough for you to put infinite solutions. Okay, so let me show you how to write your answer when it comes to infinite solutions. Please take some really good notes, okay? What you do is you go back to your two equations that are identical, okay? And you solve them for y. Well, it depends, guys. It depends if I ask you to write your answer in terms of x or in terms of y, okay? So I'm going to start off by solving for x. So here's what you do. Now watch carefully. Negative 5x equals, I don't want those negative signs there because those aren't the identical equations. You want to use the equations that are identical. So I'm going to use this one here. So I'm going to solve for x. So 5x equals 3 plus 6y. Bring the 6y over. Now divide everything by 5. X equals 3/5 plus 6y. Now what you just did is you wrote your answer in terms of y. You wrote your answer. You have x in terms of y. So when x is by yourself, please make note of this, guys. We call that x in terms of y. Okay? Now here's how you write your answer. Some books want you to put an x here, and then put a comma, and then over here put 3/5 plus 6y. Here's how I want you to write your answer, okay? We're going to say that x is this expression here. is just y. But instead of using x and y, this book wants you to use a. Okay? So there's one way to write your answer. Now what does that mean? It means a lot. It means whatever you put in for a right here. What if you put in for a here? Like let's say you want to put a 2 right here. Then you put a 2 right here. And you have one of the ordered pairs that exists on this equation. Okay? So it means a lot, to be honest with you. Now, what we did here, notice, is we got x by itself. What if I asked you to write your answer y in terms of x, not x in terms of y? Well, if I told you to write your answer y in terms of x, you take this equation here and get y by itself. So, take this equation here. You have negative 6y equals 3 minus 5x. Now divide everything by negative 6. Negative 6, negative 6, negative 6. These cancel. Y equals negative 1/2 plus 5/6 x. Okay? Now, here's how you would write your answer. Watch carefully. Okay, you would say y equals all of this. So we put negative 1/2 plus, and then we're not going to use x, we're going to use a, remember? And then over here for x, we would put what? A. So there you go. This here would be written, this here would be written y in terms of x, okay? Is how this would be written. This is y in terms of x. Okay, moving on. So either one of these answers are fine, depending on whether I ask you to write your answer x in terms of y or y in terms of x. Okay, alright, moving on, number 45. It looks really hard, but it's not. We're just going to move all of our decimals 2 places. So 2 places 5x, 2 places 3y, 2 places 21. Down here we'll move these 2 places also. So 7x plus 2y equals 16. Now we're supposed to use linear combination, so we have to either eliminate our x's or our y's, okay? I'm going to go with the y's. Why? Because one is positive and one's negative. So I have a 3 and a 2. I'd like them both to become 6's. So I'm going to multiply the top equation by 2 and the bottom equation by 3. Here we go. 10x minus 6y equals 42. Now multiply the bottom equation by 3. 21x plus 6y equals 48. Okay, add these together. These cancel. 31x equals 90. Now divide both sides by 31. And no, that cannot be reduced. So there's your answer. Now we come over here and where the x is, and it doesn't matter which equation you use, students. You can use this one, this one, this one, or this one. But I'm going to use this one here because I have some room below it to show my work. So I'm going to put 7 parentheses, and it should be 90, not 91. 90 over 31 plus 2y equals 16. Okay, well this would be, my goodness, here's where you want to use your graphing calculators, okay? This would be 630 over 31 plus 2y equals 16, okay? Bring this over, make it negative 630 over 31, okay? And then divide by 2. Now if you do all of that correctly, using the fraction button on your calculators, you should end up with negative 67 over 31. Okay, so here's your answer, 90 over 31, comma, negative 67 over 31. Okay, and last but not least, our last problem of the homework assignment, this one here. Now, it looks really difficult. It's not. You have a denominator of 4 and a denominator of 3. A common denominator is 12. So I'm going to multiply this whole top equation by 12. So here we go. 12 over 1 times x plus 3 over 4. Your 4 would cancel into your 12 3 times and take 3 times the whole numerator. And you would have 3x plus 9 cancel into your 12 4 times. So take 4 times your whole numerator here. 4 times y is 4y. 4 times negative 1 is negative 4 equals, and then 12 times 1 is 12. Now let's quickly simplify that, and we'll have 3x plus 4y. Now 9 minus 4 is 5. Okay, positive 9. Negative 4 is 5. Bring the 5 over, make it a negative 5. And you're left with 7, okay? So all of this work here allowed us to take that top equation and make it look like this. Okay, so now it doesn't matter if you put the top equation on the bottom. So now I have this equation here and this equation here, because this equation here is really the top equation, just totally simplified. I'm going to take these two equations here and solve the problem. So what I'm going to do is I'm going to slide this out of the way to eliminate any confusion. There we go. And now let's slide this right here underneath it. And I'm going to multiply the top equation by 4 to give me a negative 4 here, which will cancel with my y. So I'm going to put a 4 here. And I have 8x minus 4y equals 48. My bottom equation, 3x plus 4y equals 7. So I'm left with 11x plus 55, or equals 55. Divide both sides by 11, and x equals 5. Now you can put that 5 in for x here, or here, or here, here. I'm going to do it here because I have room to show my work. So 3 parentheses 5 plus 4y equals 7. So 15 plus 4y equals 7. So 4y equals negative 8. Bring the 15 over and make it a negative 7. You get negative 8. Divide both sides by 4, and y equals negative 2. So your answer is 5, comma, negative 2. And there you go. Okay, I hope this homework outfit has been a help to you. If you have any questions, don't hesitate to call or email.